So today we want to talk about solving rational equations. These are equations that contain rational expressions. Okay. Our big goal here is to get rid of fractions, get rid of denominators, so that we can more easily solve these equations. Now the first thing that we're going to talk about will be a proportion. Do you guys remember what a proportion is? No, not really. All right, I'll give you a clue here. A proportion is A proportion is two fractions that are equal. A proportion is two fractions that are equal. So you would see something that's of this form. One fraction is equal to another one. A over B is equal to C over D. Okay, that's what a proportion is. A proportion basically is two equivalent fractions. Okay. Here's something neat that we know about a proportion. If you have a proportion, which means you have two fractions that are equal, then we know this. We know that the cross products are equal. Okay. Here's what I mean by the cross products. The cross products would be the products going across diagonally across the equal signs. So that means that A times D is equal to B times C. That's what we mean when we talk about cross products. Please do not say cross multiply, because that is really tied to something else. I just don't even like you saying cross multiply, because every time you say it, you're not doing it right. So what we're saying here is the cross products are equal. Okay, and you did this stuff a long time ago. Like if I had 7 over 4, is this equal to or equivalent to 11 over 6? Are these fractions equivalent? Is this a proportion? And the easy way to check this is to check the cross products. So that means I'm going to do this. So checking the cross products, I want to check this. Is 7 times 6 equal to 4 times 11? Is that true? No, because we get 42 and 44. So since the cross products are not equal, you wouldn't have a proportion. Okay, so that's what we mean by cross products. Now, but here's the great thing. When we're working with equations and we're solving equations, we start with the assumption that what we have is true. So when I ask you to solve an equation, we assume that the equal sign is already true, unless we come across a contradiction somewhere at the end. Okay. So if I have this, if I say solve x plus 5 over 7 is equal to 2x minus 3 over 10. See, we start with the assumption that what we have is true. Okay. So that means we assume that what we have is a proportion, which means that the cross products are equal. So if the cross products are equal, I can go from an equation that contains fractions to an equation that doesn't contain fractions, because I can just do this, the cross product. So if I multiply these two guys, if I look at the product here of x plus 5 times 10, that's supposed to equal what? Right, it's supposed to equal the other cross product, which is 7 times 2x minus 3. So now if you look at what we have here, there's no, or there are no denominators. So we've gone from an equation that had fractions to one that doesn't have fractions. And you see this a lot of times. We take things that have issues and we rewrite them to be something that we're used to seeing. Okay? So what am I going to do here with this guy? So I distribute. I get 10x plus 50 is equal to what? 14x minus 21. Now we just solved this guy, right? How are you going to move things?
You could combine like terms.
Well, I can't combine like terms still on the same side. So what I'm going to do, I'm going to move the 10x to the other side. So that's going to give me 4x. I'm going to move the 21 to the other side, and that's going to give me what?
70.
It's going to give me 71. So that means that x equals what? Right, it's just going to be 71 over 4. You can't reduce that anymore. You could make it a mixed number, but why? So this is perfectly acceptable as long as it is simplified. Questions about that guy?